Welcome to the course on data structures and algorithms. Today we'll see specifically some examples from earlier university question papers. And these are the questions most frequently, not most frequently, but all the time they used to ask the questions based upon binary search tree, and that questions are, they used to give some binary search tree, and the question is write its in order, pre-order and post order traversal of the tree. Now in order to write a in order, pre-order and post order for a given tree, I have drawn a path, traversal path, and by the same time I have marked the traversal path with a first visit, second visit and third visit. Now it's based upon the convention, the things we record in the second visit, they are in order. Things we record in the first visit, they are pre-order, and things we record in the third visit, they are the post order. Now we'll try to record the things in the first visit, and that becomes pre-order traversal of a tree. Now we try to record the first visit 25, 10, 5, 15, 50, 37 and 70. So 25, 10, 5, 15, 50, 37, 70 is a pre-order traversal of a given tree, given binary search tree. Now in the second, we'll try to record the things in the second visit. Now if you try to record the things in the second visit, we got 5, 10, 15, 25, 37, 50 and 70. Now if you look at this carefully, we can easily identify that whatever result we got in recording of second visit, it is a sorted sequence. Means it is a simple trick to understand whatever answer we calculated, we identified that answer is correct or not. If you traversing a tree in order and getting sorted sequence, means construction of the tree is correct, traversal is also correct. Now we'll try to record things in the third visit. If you try to record the things in third visit, we got 5, 15, 10, 37, 70, 50, 25. Now if you look at this, we recorded left, then right child, and then the root of these two. Means it follows in case of post order, we used to record the things left, right and node. In case of in order, we used to record left, node and right, that is L, N, R. And in case of pre-order, we used to record node, left, right, that is N, L, R. Now these are the questions asked in the university examination, and that is for 6 marks. Now we'll go to the next question asked in the university examination. This question is asked in the May June 19 examination, and that's in question 5B, and that's for 6 marks. And this question is specifically for drawing the binary search tree using a following data, and we have to show our result stepwise. Now, in order to construct a binary search tree from given data, so what is the first element we are reading is 40. So absolutely this 40 is going to become a root of a tree. Now in the first stage, a root is constructed. In the second stage, means second element we reading is 70. Now this 70, it will check with a root. 70 is greater than the root, it will go to the left. Means in case of construction of a binary search tree, we have to follow two rules. First rule is if entity is less than root, we'll go to the left part of the tree, and if the entity is greater than the root, greater than or equal to the root, then that goes to the right part of the tree. Now in this example, 70 is greater than 40, so that it will go to the right part of the tree. Then the next element we are reading is 35. Now 35 is less than 40, so that it will go to the left part of the tree. In the next stage, we are reading 20. Now 20 is less than 40, then we'll go to the left part. Then in the left part there is a 35. Now this 20 is also less than 35, so that we'll go to the left part of the tree, that is empty, so that we can make an entry of 20 in the left part of 35. Now in the next stage, so we are reading 110. Now 110 with 110 will go to the 40, that is a root of our tree. Then 110 is greater than 40, then we'll go to the right part. In the right part there is a 70, then 110 is greater than 70, then we'll go to the right part. Right part of 70 is empty, so that we made an entry of 110 in the right part of 70. Then next element is 75. Now we'll compare this 75 with 40. Then 75 is greater than 40. Then we'll go to the next, that is 70. Now 75 is still greater than 70. Then we'll go to the 110, that is 110. Then 75 is less than 110, so that in right part of 100 in left part of 110 we made an entry for 75. Now next element is 25. Now 25 is, we'll compare this 25 with 40. Then 25 is lesser than 40. We'll go to the next node, and that is 35. Then 25 is less than 35. Still the 25 is lesser than 35. Then we'll go to the next one is 20. Now we'll compare this 25 with 20. We identify 25 is greater than 20, and right part of 20 is empty, so that 25 is entered into right part of 20. Now next element we'll be trying is 15. Next element we'll be trying is 15. Now with 15 we'll compare with 40. It is less than 40. Then we'll go to the 35. It is again less than 35. We'll go to the next, that is to the 20. But here 15 is less than 20, and left part of 20 is empty, so that we entered 15 into the left part of 20. Next element is 73. Again 73 is compared with 40. it is greater than, so that we go to the right part. Then we compare with 70, then 73 is greater, so again we'll go to the right part. Then there is a 110, we'll compare with that. Now as we compare with it, 73 is less than, then it will go to the right part, then it will go to the left part. In left part there is a 75, we'll compare 73 with 75, then 73 is less than 75, so that we are making entry of 73 into left part of 75, and this is the final construction of a binary search tree from a given data. Now, similar kind of the construction is for another example, and again it's for 4 marks, and data is 10, 60, 40, 28, 14, 50 and 5. So immediately 10 is the first element, so it's going to become a root. Then next is 60, we'll go to the right part of 10, 40 which is greater than 10 but less than 60, so that it will go to the left part of 60, and similarly all other elements, and this one is the final construction. 10, 5 is left, 60 is right, to the 60, 40 is left, to the 40, 28 is left, 50 is right, and to the 28, 14 is the left element. This is the final construction of a binary search tree from given data. So thank you so much for watching the video. We'll meet in the next video.